Okay, here we are with a fancier. This is Mulhall.
Trunkel here.
We're in the modern physics lab, and now we're going to do a fancier version of the Michelson Interferometer. We're going to measure the wavelength of laser. We're going to measure the index of refraction of air, and there's other possibilities that we'll tease you with later on. This is much fancier. I'm going to go through the components now and show you what they are, and then Nick will show you how you make a measurement. So here we have our laser beam. This controls this electronics box. Turns on and off the laser. So we have the laser beam. We have these two mirrors here. These are just setting up the beam optics. So now all you need to worry about is from here forward. We have it already set up for you. We're going to. A note actually on the philosophy behind the modern physics lab. We think that this is the place where you learn how to use equipment. Maybe in the more advanced labs or in the optics labs, we'll let you set them all up and stuff like that. So we've set a lot of stuff up for you, so you can just come in and kind of use it in a more basic way, because we don't want to be too distracted by that kind of stuff. That's a different lab for a different course. Okay, so we have the laser comes through here. This is our beam splitter. And here's one mirror and there's the other mirror. So these are the arms 1 and 2, exactly like we had over there. And now the spots go over, and we've got these two spots on the screen. If you look over there on the page, we've got these two spots. We can adjust the position of those two spots by, this is the X knob, and on the back of this mirror is the Y knob, and they play the same role as these two knobs over here. It's interesting to see how this thing works. If you look down on top of it, Majid, this is a solid block of aluminum, and it's sliced. It's only been held at two pieces here, two slim little, just two little lips of aluminum. Everything else has been drilled away, and I can see you can tilt it like that. Now, Majid, look at the dot. When I'm tilting this, look what happens to the dot. This is, instead of tilting this mirror here, this is more unstable. This is really stable and it doesn't vibrate. Okay, so let's get the thing aligned. Now I'm going to align it like this. Oh, I'm sorry, I should mention now that this is the mirror that moves forward. So, Majid, if you look at a bird's eye view, this rod comes in here, and I can push the whole mirror forward. That's how I change the optical path. You know, you're sitting there thinking it doesn't look like it's going very far. It doesn't have to go very far. It just has to, like 1 millimeter is a huge amount to play when you're dealing with wavelengths of light that are like 600 nanometers. That plays the same role as this mirror here. And then remember when we turn this, we move this mirror backwards and forwards through a lever system underneath. This time what we're doing is we're turning this vernier here. Okay, so we'll get the dots lined up. I know, look at that. Now if I push on the table, you can see the fringes going backwards and forwards. And now the last thing. So far it's still business as usual. It's still very similar to this, except it's just more like better, fancier components. But the joy happens where instead of counting, because the pain you suffer counting fringes, we're going to count them electronically. We have a light detector here. When light hits it, the voltage comes out the back, and we put it into this electronics module and watch what happens when the light changes on it. Nothing happens. Okay, so we can cut there.